So what if you're in a situation, you're looking for how things change, and there's more than one x in the equation? It shows up more than once. We start with the basic idea. If y equals a times x to the nth power, then dy dx equals n times a times x to the n minus 1. So what do you do in that situation? Well, basically, you repeat the process. So for example, if you had, say, y equals 2x cubed plus 4x to the fourth power, we've got two instances of x. We have x cubed and we have x to the fourth power. What do you do then? Well, it's actually pretty direct. You're just going to do the same thing you've always done before. So we have y equals 2x cubed plus 4x to the fourth. In this case, we have two n's. We have a1 equals 2. We have a2 equals 4. We have n1 equals 3. And we have n2 equals to 4. You're just going to repeat that. Same process twice. So dy dx equals, you take the 3 down, 3 times 2x to the 3 minus 1. Take the plus sign down, 4 times 4x to the 4 minus 1. And that simplifies to 6x squared plus 16x cubed. And that's your slope. Every value of x you get, you wind up with a different trade-off with y. Another example, and I use this because of the problems we frequently have associated with negative numbers and negative values and keeping track of the signs. Suppose y is equal to 3x squared minus 2x. Well, in this case, we have a1 equals 3, n1 equals 2. A2, the second observation of the constant, is equal to 2, and n2 is equal to, in this case, 1. Remember, if you don't see an exponent, then that exponent is necessarily 1. So dy dx is equal to 2 times 3x to the 2 minus 1. This is minus, don't forget the negative sign in there. We have 1 times 2x to the 1 minus 1. That's going to come out to 6x to the first power minus 2x to the 0 power. So let's see, that would be 6x. We ignore the 1 as the exponent. And 2 times 1. Remember, anything taken to the 0th power is 1. So this just equals 6x minus 2. And that's how you do derivatives, find the slopes. We have two observations of x in the same equation.